So our pi over 12 questions fill in the part of our unit circle that we don't know. And the way that we figure them out, so we'll start off with cos of pi over 12, is we use the values that we know from our pi plate. Like we know what pi over 3 is, pi over 4, and pi over 6 are. We know all of those. And if we can add or subtract them to get a new angle, we can figure that out using our sum and difference identities. So what I have here with pi over 3, pi over 4, and pi over 6 is I've changed them to have a common denominator of 12. Pi over 3 is 4 pi over 12. Pi over 4, 3 pi over 12, and pi over 6 is 2 pi over 12. So can you use any two of those to add or subtract to get pi over 12? Yes. Can you give me one example? Sorry? If you take pi over 4 and minus pi over 6, that would be 3 pi over 12 minus 2 pi over 12. That would give you 1 pi over 12. Can you see another one? Yeah, you could do the 4 pi over 12 minus the 3 pi over 12. So there's more than one way that you can often come up with an angle. And we're going to find out that there's lots of ways you can come up with the angles. Because you are not restricted only to use the three that are here, but we're going to later use any pi over 3, pi over 4, or pi over 6 family member. So if we choose one of these for pi over 12, so let's say I choose 4 pi over 3 minus 3 pi over 12. And then I change I like to write it with pi over 12s first because it's really easy to see that inside the brackets that's equal to pi over 12. And then after that, I can change things back to what they were originally. 4 pi over 12 is really pi over 3. 3 pi over 12 is really pi over 4. And so pi over 3 becomes our alpha. Pi over 4 becomes our beta. And if we go to the cos alpha minus beta formula, we just get 4 values that we already know from our pi plate. We know the value of cos of pi over 3. We know cos of pi over 4. And same thing for sine of pi over 3 and sine of pi over 4. All right, test your memory. What is cos of pi over 3? 1/2. What's cos of pi over 4? Square root 2 over 2. Sine of pi over 3? Square root 3 over 2, and sine of pi over 4, square root 2 over 2. So since you know each one of those, you can put those values in. And then multiply fractions. You'll have a common denominator of 4, so you can add the tops. And we get that the exact value of cos of pi over 12 is the square root of 2 plus the square root of 6 all divided by 4. So if you were going to add this to your unit circle, you now know the x-coordinate of 15 degrees. Or you now know the x-coordinate of pi over 12. We could do the same thing with sine, and you could find the y-coordinate. And then you could add that to your unit circle. So our first example was using 15 degrees or pi over 12. Our next example here is looking at sine of 75 degrees. So 75 degrees, I'm going to slide this up. This is equal to sine of 5 pi over 12. But now we're working in degrees, so now you got to think, on your pi plate, do you know two values that add or subtract to get 75 degrees? 45 and 30 would work. Can you come up with another one? Using your pi plate values that make 75. 45 and 30, obviously I would want everybody to use that because it's so easy to figure out. But I want you to come up with another one that adds or subtracts that gives you 75. 135 minus 60. Good. But we'll use 45 and 30. And it doesn't matter the order because you're adding, so you could have had alpha as your 30 and 45 for your beta. But then we go to our sine alpha plus beta formula, plug those in, use our unit circle to figure everything out. And this one also is root 6 plus root 2 over 4. In fact, you're going to find out for all of your pi over 12 family members, for sine and for cos, you will always get a root 2. You will always get a root 6. And you will always have it over 4. But the difference is sometimes the root 6 will be negative. Sometimes the root 2 will be negative. So that part changes depending on which pi over 12 you're looking at. So one of the things that I had listed earlier with pi over 12, when I change things to pi over 12, can you see that only the pi over 3 family makes an even number? And I wrote that above in red. Both the pi over 6 and the pi over 4 families make odd numbers. No, sorry. Only the pi over 4 family makes odd. Both the pi over 3 and the pi over 6 are always even. And this is going to be important because if you're finding a pi over 12 family member, your pi over 12 family members will always have an odd number on the top. Because if you have an even number with pi over 12, let's say I have 8 pi over 12, what can you do with that? You can reduce it. And if you can reduce it, it won't be part of the pi over 12 family anymore. So all of our pi over 12 family members will have an odd number on the top. And the reason it's important to recognize that only the pi over 4 is an odd number is because if you add two even numbers, you always end up with an even number. If you subtract two even numbers, you always end up with an even number. The only way to get an odd number is if you use a pi over 4 family. So when we get to this next example that we're going to do, which is cos of 17 pi over 12, we use that idea that we have to start with somebody from the pi over 4 family because that's the only one that's going to give us an odd number. And it doesn't matter which family member you start with. In fact, I'm going to do it off to the side before we even start here. Cos. Cos. You don't have to write this down. But I have 4 family members already started, right? Pi over 4 is 3 pi over 12. 3 pi over 4 is 9 pi over 12. 5 pi over 4 is 15 pi over 12. And 7 pi over 4 is 21 pi over 12. Can you tell me what would have to go with 3 pi over 12 to get 17 pi over 12? What would I have to add or subtract, by the way? I'd have to add. That's pretty obvious because we need to get 17 and we're only at 3. What would I have to add to that to make 17? 14 pi over 12. Okay? What about 9 pi over 12? What would you have to add to that to make 17 pi over 12? 8 pi over 12. Good. What about 15 pi over 12? You'd have to add 2 pi over 12. What about 21 pi over 12? You'd have to subtract 4 pi over 12. Now, the interesting thing with each one of these, we already know that these ones that I'm going to circle in blue, those ones are all our pi over 4 family members. What has to go with them is another thing from your unit circle. But if you start with a pi over 4, reduce 14 pi over 12, what do you get? You get 7 pi over 6. Is that on your pi plate? Yeah, so that would have worked. Reduce 8 pi over 12. What do you get? Two pi over 3. Is that on your pi plate? Yes, it is. Reduce 2 pi over 12. You get pi over 6. Obviously, that's on our pi plate. And finally, if you would reduce 4 pi over 12, you would get pi over 3. So one of the things that students get stuck on this is they're like trying to figure out two things that work, and they're randomly picking two angles. It's not that hard. If you start with any pi over 4, and it doesn't matter which one you start with, because they will all work. When you figure out what has to go with it and then reduce your fractions, you will always get two values from your pi plate. So if we start with a pi over 4 family and then reduce it, we will always get something on our pi plate. So I'm going to erase these ones here. And I had decided to start off with 21 pi over 12. Sometimes people like to choose one that's the closest to their value. Sometimes people like to just start with pi over 4, because that one is the most regular one. But they're all going to work. So I chose 21 pi over 12. When I reduce those, that's my 7 pi over 4 minus pi over 3. What's going to happen when we get to these bigger angles is now when we choose we have 7 pi over 4 is our alpha, pi over 3 is our beta. When we go and put those in, now we have some angles that are in quadrants where sine or cos might be negative. 7 pi over 4 is in quadrant 4. In quadrant 4, cos is positive, so this is still root 2 over 2. Cos of pi over 3 is in quadrant 1. That's still positive. That's 1/2. But sine of 7 pi over 4 is in quadrant 4, and sine is negative in quadrant 4. So that's why we get a negative root 2 over 2. And then sine of pi over 3 is root 3 over 2. So again, when we multiply this out, we get our root 2. We get our root 6. This time the root 6 was negative, and it's still all over 4. Sometimes on the exam they have cos of 17 pi over 12 as part A of the exam question. And then in part B, worth only 1 mark, is secant of 17 pi over 12. What's the answer to secant of 17 pi over 12? It's just going to be the reciprocal of the answer you got for cos. On some they used to, on some final exams, just start off with, say, find secant of 17 pi over 12. And if the student didn't think to first find cos of 17 pi over 12, they got no marks. It was like a 4-mark question. A lot of people were getting 0 out of 4. So then later on in the exams, they said, okay, maybe that's too harsh. Maybe we should check first, can they do cos of 17 pi over 12? And if they get that answer, and I ask them secant of 17 pi over 12, do they know that secant is the reciprocal of cos? And that means the angle, notice the angle doesn't change. It's just the answer is the reciprocal. So try this one on your own. And then from the homework, if you get this one done, you can do number 7.